Wow, and welcome everybody to the Daily Space Weather. Do you want some imagery of the sun? All right, we thought so. Here's 304 angstroms from the Solar Dynamics Observatory. Talk about a lot of activity kicking off, all at the same time. We're a little inundated. This is ionized helium in ultraviolet light. And we saw the largest flare of quite some time here in M4.7 from sunspot 2860. And we've got spectacular imagery once again of that situation. First, the colorized magnetogram. Sunspot 2860 has largely remained stable. The likelihood of additional solar flares and coronal mass ejections is very high. And there are multiple other sunspot groups as well, like 4 other sunspot groups at the moment. Here's 171 angstroms. And if you're wondering, peak flux occurred around 611. We've also got communications failures and all kinds of other things to cover on today's video. It's pretty intense. This is 171 and 304 angstroms composite imagery. One of my favorites. There was a coronal mass ejection, and the Space Weather Enthusiast dashboard already forecasting an Earth strike. I would tend to disagree. I think this is going to miss the Earth to the south, but we'll get to that in a minute. Here's a close-up of the southern hemisphere. And we've got some even more extreme close-ups for you later in the video. Just spectacular. The 10.7 centimeter radial flux still at 90 solar flux units. So there you go. There's the 1-year chart of the radial flux. The black line's the radial flux over the past year. The red line is the sunspot number, and you can see how proportional those data sets are. Next, Space Weather Enthusiast dashboard. We see additional geomagnetic unrest and storms forecasted here for tomorrow, late in the day and early in the day on the 30th. So a whole lot of things happening at the same time. And here is the Enlil forecast. It looks like the coronal mass ejection, according to this model, is expected to strike stereo A and Earth. I definitely thought this looked like it would miss to the south. But in any case, there's the forecast from the Space Weather Prediction Center. So here's a view from stereo A. If you're wondering where stereo A is located, it is at Lagrange point 5. Right here, it looks at the sun from behind the Earth, orbitally speaking, but it sees space weather ahead, hence the name stereo A for ahead. So it trails the Earth orbitally, but it sees space weather first. And since the Earth would be off to our right in this imagery, I don't know what they're talking about. It looks like almost all of the ejecta here is directed southward. So you can see the way this is kind of headed in this direction. Most of it, if not all of it, Earth would be off in that direction. Those images there are the raw data, and the difference imagery, which is just the raw data subtracted from the previous raw data. Sometimes it gives us a little better idea of what's going on. And let's take a brief look at seismicity. It's pretty calm here over the past 24. We're just going to scroll up the list. One of the larger quakes of the past 24 was a 5.6 at Philippines. The South Sandwich Islands region continues to rock and roll. That tri-boundary there between the South Pacific Plate, the South Atlantic Plate, and the Antarctican Plate, by far the most seismically active portion of the planet at the moment. We don't want to spend much time on this today as it's not that active. And the rest of stuff is really active. We've also got a meteorology segment we're going to put up. It would have aired before this video. Make sure you check that out if you haven't. As we've been forecasting this for days, let's check out volcanoes at volcanodiscovery.com. Karimsky exploding, 10,000-foot ash plume over Kamchatka. Shiveluch exploding, 14,000-foot ash plume from Shiveluch over that same Russian peninsula. Fukutoku Okanoba, the seamount has changed shape. So there's a bunch of pumice at the underwater volcano. No explosive eruption detected while observing. Subanosejima, flight level 180, major uptick there at Subanosejima. It's producing an 18,000-foot ash plume now. So an uptick there around north of Japan, south of Kamchatka. Semisopochnoi in the Aleutian Islands, exploding, producing a 13,000-foot ash plume. And now Atka has had its alert level lowered to green. So another Aleutian volcano there becoming less active. Fuego exploding, 15,000-foot ash plume over Guatemala. Nevado del Ruiz exploding, 19,000-foot ash plume over Colombia. Revenador exploding, 15,000-foot ash plume over Ecuador. Sabancaya exploding, 24,000-foot ash plume over Peru. And today is not a good day to pole vault the caldera. Please don't, but do visit smAsho.com. Next star goes magnetometer over the past 3 days. Yowzers. We saw a sudden spike in the magnetometer here right after the solar flare. So this sudden spike here, perhaps it's a coincidence, perhaps not. But in any case, there you go. Spiky readings here on the GOES magnetometer. There's been a geomagnetic storm, incoming plasma, all kinds of stuff happening. Let's take a look at the heliospheric current sheet. It's the top view ecliptic plane field plot. And we are expecting Earth to remain in a North Pole current sheet for the foreseeable future. Here you can see it in green. North Pole current sheet shown in green, red. Red polar current sheet shown in South Pole current sheet shown in red. Here's a line of sight view of the same data. And you can see the colorized, the non-colorized magnetogram there from the National Sunspot Observatory. The main feature remains Sunspot 2860. It's rowdy, it's large, and it's in charge. Here's the line of sight coronal hole plot, and yeah, we've got coronal holes as well. And about a week ago, we started forecasting a 60-day massive increase in coronal holes. It's well overdue. Anyway, there's the latest image. This also shows you the sun's B field in blue, and you can see it's starting to look like the cycle is progressing. Thank goodness. Next, the flare monitor and detected sunspot groups. We may have 5 sunspots at some moment today, as there's one growing behind sunspot 2860, but there's also one setting ahead of it, sunspot 2862. And we've only got one alpha class sunspot at the moment, sunspot 2861. The rest are beta class and more likely to produce major flares. You can see the flare probability monitor up to 62% there. Here's the geomagnetic storm we just talked about earlier. KP index made it up to 5. It would have produced some aurora most likely. And we're still in a period of geomagnetic unrest. Current KP index of 4. So lots and lots of stuff going on. Here's the massive radio blackout that was caused by that M4.7 class flare. It was centered right over the Bay of Bengal, really, east of India right there. So some massive radio blackouts there as the ionosphere absorbs instead of refracts your radio signal. So this is a great way to look at solar flares. For example, if the X-ray flux website is down, if this one is still up, you can estimate the size of flares if you are familiar with this data. So just a lot of stuff going on, and quite an interesting day for space weather. Here's the X-ray flux. Again, the peak flux of that M4.7 flare. Let me just press refresh on that. Peak flux was at about 10 after 6 universal time there. No spikes in the proton flux, so that flare did not send any relativistic particles our way, at least at the moment. No spikes in the proton flux, an indication that there's not a lot of ejecta headed Earth's direction, in my opinion. Continuing on to the real-time solar wind. And we saw the BZ here, this red line up top. This climbed out of negative territory, and as we saw that happen, we saw geomagnetism drop. So it's a well-known fact that a negative BZ, especially a strong, steady negative BZ component like this, and that look at the power of the field there. Total field there at 16. So 13, negative 13 BZ and a BT of 16 there. Very strong field showing up at that moment. And we've largely converged on the 0 line here. So only half of the strength there in terms of the total field. And there was also a coronal mass ejection strike mixed in here. This looks like a coronal hole wind stream to me. And we may be seeing a little uptick in the solar wind velocity here. I'm expecting one to be coming any moment now. Anyway, we've seen the solar wind density return to a anomalously low amount here. 0.56 protons per cubic centimeter is the current reading, or close to it. It looks like less than 1, so that brings up possibilities of errors there, and that's what these orange and red lines mean down here at the bottom. It looks like solar wind speed is just under 400 kilometers per second, about 375. Solar wind density probably around 2 protons per cubic centimeter. And we're expecting additional inputs there. Looking like some bad data. We've got some oddities here in the magnetosphere. So check out the Geospace Magnetosphere movie. This could be some anomalous data. But it does coincide with extremely low density. So you can see an extremely low density region there according to the space weather modeling framework. We don't always show the density. There's a little increase in the density. And then here it's going to drop back off again. That's 4 hours of data. Here's the pressure. Again, as modeled by the space weather modeling framework. So it's as if, according to the space weather modeling framework, that the plasmasphere is very shrunken at the moment. A pretty strange magnetosphere movie for today's video. Starting to look a little bit more normal there. So a very diffuse solar wind at the moment. We can expect that to increase precipitously and perhaps suddenly. So here is the Geospace Delta B map. We're showing the polar view to show the likelihood of auroras. Again, we've seen the geomagnetism calm down a little bit here. We're still in a period of geomagnetic unrest, so there may be a bunch of aurorae. We'll show the forecast for that also in a minute. First, the synoptic global view here. And ground magnetic perturbations are showing you a model of Geospace Delta B. The Earth's B field, the field that goes through the magnet. Sort of the net overlap of the two polar fields. Anyway, that's also 4 hours of data. Here's the auroral forecast. And you can see some quite significant aurorae there. Mainly over northern Europe and Asia. Then moving into Canada. And then calming down toward the end. If you're wondering where stuff is in the solar system, here's where it is now. There's where things will be in a week as we approach another full moon 4 days into smAshtember. It's going to be a smAshtember to Omash member, folks, as our official website kicks off on September 1st. It's already fully operational, though, so go check it out at smashomash.com. There's a link to the Smash team. Here's a star chart at in-the-sky.org. I face mine to the south as I'm currently facing the south. The ecliptic is in that direction, which is this yellow line, and the moon is near the apex of its passing down the ecliptic. Where were you when Cygnus rose? All right. We're going to do a brief cosmology segment today. It's going to be very short. We're not going to pick any random numbers or anything like that. We're going to show you this. Anybody know what that is? Anybody? Anybody? It's the Mars rover. Check it out. A close-up of a Mars rock, folks. Very high-res image here. If you want to go look at it yourself, it's apod.nasa.gov, the astronomy picture of the day, and let's look at cosmic rays. Now, if you were standing on the surface of Mars, you'd be exposed to more cosmic rays than you'd be standing on the surface of the Earth. And let's check and see what's going on with cosmic rays. So there's the Apatity neutron monitor, and you can see a downtick over the past 30 days here. especially in the past about 10 days. So that's Apatity, Barentsburg showing the same graph. We'll go farther south to Athens, Greece. There's the Athens monitor. And you can see a similar graph there. What's interesting about this is we've recently seen a massive solar uptick, and we've seen an increase in cosmic ray flux as well. And I've got some theories about this. I guess I could call it a hypothesis. Oh, and as far as Athens, an uptick at Athens over the past 30 days in cosmic ray flux. Next, going farther south to Mexico City, an uptick at Mexico City over the past 30 days. And this signal here showing up in all 4 of the monitors we've just shown. Whoops. And last but not least, we'll go back up north to Oulu, Finland. Oulu, Finland corroborating that data. And a small uptick there at Oulu over the past 30 days, despite an increase in solar activity. So here's DOMB Antarctica, an uptick there at DOMB Antarctica, and an uptick at DOMC Antarctica. And that's today's cosmology segment. If you don't know about cosmic rays, look them up. Cosmic rays are similar to what the solar wind is. They're primarily made of hydrogen nuclei, but also the rest of the heavy elements. It's about 90% hydrogen nuclei, and the rest is, of the rest, it's mostly helium nuclei, otherwise known as alpha particles, electrons, and then a very small portion of the remainder is the rest of the heavy elements, traveling at relativistic speeds through space. The sun produces cosmic rays, but primarily when we say cosmic rays, we're talking about interstellar cosmic rays coming from outside the solar system. Let's go inside the Earth system. We've got some charging hazards for satellites over places like Central America, even Florida. We've got some significant surface charging hazards, and we've got some likely communications breakdowns because of a sudden uptick in the electron flux. Here's the 1-year chart of the electron flux from Solon.info, and this is yet to be updated. This is going to be way up here somewhere, as we are well into warning territory here, about double the electrons required to get into warning levels. So communications breakdowns, additional ones, in addition to, radio blackouts from solar flares, can be going on. Don't be surprised to see websites down and so forth. Those relying on satellite communications may have CCD bakeouts, where the charge coupled device is shut down to prevent them from being damaged. So if the satellite doesn't have the data, you're not going to get the data either. There's the electron flux over the past 3 days. And you can even see a disparity here in the measurements from the GOES 16 and the GOES 17. The N's and M's stand for noon and midnight local time for the satellites. So here is the forecast model. And this looks like it's yet to be updated as well, because we don't see those high levels reflected on the data. The yellow diamonds are the observation, and the green boxes are the forecast. Diagram of the atmosphere. Well, the Van Allen belts, I'll say. And check it out. Here's this very high electron flux anomaly happening over Western Africa and the Eastern Atlantic. So that would have caused huge GPS errors for anybody in those areas. And we'll rock this back and let it play through for one run, as there's, let's just say, lots of more stuff to cover even still. And again, make sure you check out our meteorology segment if you haven't, especially if you're in the path of the coming hurricanes. Yes, 2 of them. Here's another diagram. Distances are now in kilometers. Feel free to pause the video there. We're looking at the ionosphere, and we see some anomalies. So we'll show you the anomaly map. First, the ionogram. This is courtesy of Australian Government Bureau Meteorology. And we see some anomalies here, primarily on the high-frequency side. Keep in mind, as we approach an equinox, geomagnetic effects are much more likely, especially with these upticks in solar activity. So there is the Latest image from 10 o'clock Universal Time, some low-frequency anomalies around the South Polar region. Here's the anomaly map. This is departure from the 30-day median. And you can see high-frequency anomalies around the equator and low-frequency anomalies around the poles. Some high-frequency anomalies in the southern hemisphere as well. There's the latest image. That's from 10 o'clock. And you can see those low-frequency and high-frequency anomalies on the same map there. If you're only here for the space weather, you should check out our meteorology segments as well. We just did another great meteorology segment. It would have premiered before the daily space weather. We've got a playlist for it, youtube.com/smashamash/playlists. Let's take a look at the latest imagery here and check out sunspot 2860. It is spectacular. Multiple umbrae there. The likelihood of additional major flares still there. Sunspot group setting over here, that's beta class. There's sunspot 2859, still beta class. There's another sunspot, I've lost track of the numbers. That's alpha class. And we may see more forming here as well. So there looked like there was one forming here behind sunspot 2860, and indeed there's that one. So lots of activity all of a sudden. Here's the latest magnetogram. There's 2860, and it is pretty rowdy. Likelihood of additional major flares still there. There's that new group. We're just going to kind of surf around here. Here's the northern hemisphere. There's sunspot 2859. And here is this setting sunspot group. I don't remember the numbers. To quote Einstein, never memorize something that you can look up. Einstein realized that the human mind has spatial limitations. It's almost like a hard drive, folks. Your brain isn't all that different from a computer, believe it or not. It's a series of on-off switches, which is exactly how a computer works. Anyway, here's the latest GOES 16 imagery. We won't spend a lot of time on this. We don't want the video to be too long. Here's some very current imagery from El Teide, Spain. Again, coronal mass ejection and solar flare warning, both in place. A warning for solar flares and coronal mass ejections. Here comes some more spectacular imagery. It's the southern hemisphere in 131 angstroms. And for you new viewers out there, 131 and 94 angstroms. 131 and 94. Those are the two wavelengths that show 10 images per minute instead of only 2. They're specifically designed to watch solar flares. So those are our favorite for this sort of phenomenon. Here's an extreme close-up. Maybe put on your sunglasses for this one. Just kidding, folks. The white portions are a lot of iron. So a lot of fusion happening here on the surface of the sun. Nuclear fusion before your very eyes in the form of a major solar flare. It's an M4.7. And we'll close things out with 94 angstroms. Just spectacular imagery here. So this is 94 angstroms. And again, peak flux occurred here around 6:10 Universal Time today on August 28th. 8:28 has been an interesting day already. And it's only 20 after 6 a.m. here in Lehigh Valley, Pennsylvania. Thanks again for tuning in, folks. Congratulations on realizing our channel exists. Please tell your friends, foes, science noobs, and science pros about the channel. And may that solar wind be at your back.